Hi guys, okay, morning, how are you guys doing? Today we're going to discuss the different uses, why one should use a Java.lang exception or a runtime exception. Now, if you see what I was just now, what I was trying to show there is the mask that I was wearing. That's basically to catch any of the particles, the small particles of the coronavirus. It's a sort of protection, something I can catch to prevent it from happening. And then the helmet I was wearing, I'm not that young anymore, and even the youngsters should wear a helmet when they go cycling, because you cannot predict if something is going to happen. So when that happens, hopefully the helmet will stop it. But even if I do fall and I've got a helmet, sometimes it can cause serious damage. I could dislocate an arm or something. So see that as an error. Okay, it's not exactly, but the analogy you'll get to it, I think, is close enough. Okay, so what I'm showing here is the main classes and the hierarchy of the exception. Now you'll see that there's obviously the Java lang object, or is a superclass of all classes in Java. All classes inherit from that one. And then your first main superclass of all exceptions is your throwable, Java lang throwable. And then it's further divided into two subclasses. The one is the Java.lang exception class, and the other is the Java.lang.error class. Okay, we'll come back to these two, but there's a further class down here, another subclass, Java.lang.RuntimeException. Now, what's important here of these, especially these two here, is that all exceptions that have to be caught, so the mask in this case, will inherit from the exception class. So any other class like file not found, IO exceptions, SQL exceptions, and so on, they inherit from the exception class because they have to be handled. In such a case, in Java, you'll use a try catch finally statement or block, and those that don't have to be handled will extend the runtime exception, and the very serious areas those that you shouldn't handle and catch. Okay, we're going to come back to these now, just as an example. Let's just go through this theory on exceptions before we carry on. So like I say, point one is they all inherit from the Java.lang.throwable. Okay, all your exceptions inherit from the superclass throwable. Then what else I state here is that the runtimes are exceptions that inherit from Java lang runtime exception. So runtime exceptions will all inherit from your illegal argument exceptions and things like that. Arithmetic exception, null point exception, and so on. Okay, then you get point 3, which I stated that a runtime exception does not need to be handled or declared. It does not need to, but you can if you find the need for it. Okay, and then you get the other one here. Exceptions that inherit from exception class must be handled or declared, which is this one. If you got an exception here, like the file, the IO exceptions, they will inherit from this exception, and they must be either declared or handled. Handled, in other words, try catch, and so on. Okay, so why are there different types of exceptions, including the Java lang error class? Okay, let's discuss why there are such things. Okay, the runtime exceptions are intended for programming errors. Errors that things like a user goes and enters a 0 where he shouldn't have entered a 0, and so now you divide, sorry, you divide it by 0, and it would throw an arithmetic exception because you cannot divide by 0. That's an example of a runtime exception. There are many examples, so we'll leave it at that. Yeah, let's go with the other one that I've got there. So you got an account object, an account class, and you don't want illegal state. In other words, someone will enter the wrong ID or account number or something like that, and now the object is in the wrong state, and it could cause havoc, like this guy drawing money from another account or something like that. So you rather throw an exception there because the object didn't initialize properly. It's not in the correct state. Not all the fields in that object were initialized properly for some reason. Then you throw a runtime exception. Okay. Then you get checked exceptions. These are exceptions that can be recoverable. An example of this would be user is searching for a file. So you got an app that searches for files, and it enters the wrong file. So it will throw a file not found exception, which is a court exception, and it goes back to the user with some information. Say, hey, are you sure the file name is right? And enter the new file name. Okay, so it's a court exception. It's a recoverable error. In this case, actually a recoverable exception if you use the Java language terms. And like I said before, you can catch a runtime exception. Like you can catch a division by 0 and have him put something else, but usually you would use a runtime exception in most cases, like I said before, to protect the state of your objects. Now, but a checked exception, in other words, a checked exception, those that extend like from java.lang.exception, those you have to catch or declare, has to be in the try catch block so that you can deal with them, and they are recoverable. Okay, the last one which I want to mention here, which you shouldn't try and handle or declare, is similar. Let me give you this example. I'm going on a long trip, and I usually check the oil. So I did check it this time. It looked fine. So I did my checks and everything. Off I go in my car, and something hits underneath the car. I'm busy driving, and it hits an oil sump, and the sump starts leaking. Eventually, the red light is going to come on, and there is actually nothing I can do, but I must pull over before I cause major damage. Now, in the computer terms, is something wrong, and we will cover it just now, and say it runs out of memory, or there's a disk failure, your hard disk something vanishes. It's a serious area which your program cannot handle. It will throw an out of memory or an out of or some error, and the system will stop there. Yeah, the program will stop there. Okay, so just to carry on here, and I'd say note, if you believe the condition is recoverable, then you use a checked exception. That is what they for. But you cannot foresee every possible thing that can go wrong in this world, and that's where Java will throw a runtime exception, and in very serious cases, it will throw an error. Okay, what's also important is you never try and catch an error, but you could catch a runtime exception, but you must catch a checked exception. So the checked exception must be in a try catch finally block, and we're going to look at some examples next. So we'll get to that now. All right, okay, so let's look at some examples of exceptions. What I'm going to do is we're going to start with a runtime exception, and what happens if different exceptions occur. And what I've done is I've put this on the side so we can look at it nicely. So let's start with the first one. Now you'll see the first one I'm going to just uncomment this line. So when the main method runs, you will see it will come through. The only uncommented line is this, and it will call this throw runtime exception, which is a method here. I'm just going to open a method here. And what's interesting enough, I just want to show you guys, for those that don't know, and runtime exception, which illegal argument exception is one of those. And let me just show you that quickly. I've got a little application. I actually ran it before, but I'm going to run it again for you, which I can then print the class hierarchies. And you see the class Java Lang arithmetic exception extends runtime exception, which extends exception, which extends throwable and object. Like I said, you see runtime exception, there it is. Arithmetic extends that one. It doesn't have to be caught, but you could. I'm not going to catch it in this case. What I want to show you is I can actually create a new. I can create it like an object. And what I'm doing is, there's a Java keyword here was telling me throw. So I'm I am throwing it in my code. Okay, the word doesn't come out programmatically, whatever. But anyway, I'm throwing it as an illegal argument exception. Okay, so now if I run this code, and I'm just going to run it, it saves and it runs it, and you'll see at the bottom here, hey, it came here, something happened, and it threw a Java Lang illegal argument exception, and it even tells me at what line it started. Let me just click there. It started here at line 103, and then the next thing it went to this one, and this one actually threw the runtime exception. So this is one of the examples of a runtime exception, a legal argument exception. Like I showed you guys here, it's through an illegal argument exception, which is a subclass of the runtime exception. Now I'm just going to comment this line out, and the one example I mentioned is if you divide an integer, a 1 by a 0, you'll get an exception, an arithmetic exception. And if we run that code now, that one there, which I'm trying to print, 1 divided by 0 is equal to 1 divided by 0. If we run it, it's telling me I've got an arithmetic exception, and yeah, there it is. Sorry, I mentioned that one, the illegal argument exception, but what I actually was showing you is an arithmetic argument exception. So let me just do the other one quickly. Java ch my little app, and I'm going to say what's it? Illegal argument exception. Illegal argument exception. Now it has to be spelled right, otherwise I won't get it. Illegal argument exception looks right. And if I typed something wrong there, so let's just try again. What am I typing wrong here? The easiest is I'm just going to copy it there. Sometimes I don't see it. I'm looking at it and I don't see. Oh, of course, it will never. Remember that your names of your classes include the package, the full name, qualified name. So I would have to put here java.lang illegal argument exception. Hopefully I got everything right there, and there it is. My little app is thrown. As you can see, just like the other exception, illegal argument exception also extends the runtime exception. So they're both runtime exceptions. I didn't catch it or declare it. We'll come back just now to that, because like I said, these you don't have to catch or declare. Let me just show you another example of this. I'm going to comment that code out there so that it doesn't run. I'm going to uncomment the next one. Now, when you divide 1 by a double, will it throw a runtime exception, an error, or a court exception? Let's see what it does. And Java tells you that when you divide a double by 0, it's a number that's undefined. Okay, so it doesn't throw an error. It's built into the Java programming language, and mathematically it's an undefined number. You shouldn't divide. You cannot decide a double whatever that is. Okay, so that is your runtime exceptions. Next we will discuss the court exception. Okay, now for the court exception, just before you recall me telling you guys that the court exception is that special exception that extends java.lang exception, and it has to be handled or caught. So let's, before we do that, also spoke about the try catch block, but let's do the handle and the things quickly and caught. So you'll see that I've got the throw caught exception here, which will call this method here. I'm just going to open it. Just minimize that one. Okay, before I run this code, I'm just going to comment that code out, and let me just say throws new of IO, or let's call it file not found exception. Not found exception. Okay, so I'm telling it programmatically to throw a file not found exception. And let's just go look, what is a file not found exception? So if I go to my app and I say Java file hierarchy java.lang dot file not found exception. As you see, looks like I spelled it right. When you run it, obviously something is wrong, so let me just check what am I doing wrong. File not found exception. I'm just gonna copy that, just bear with me. So let's just type it out again. Oh yes, now the file not found exception is in the IO package and not in the lang package. I can type in there file not found exception. It's in a slightly different package. Remember in the beginning I told you that these are all, if I didn't mention it, I'm not sure, these are all in the Java lang package, but your IO package has got all the specialized classes that deal with IO, reading and writing files and so on. And you can see that the Java IO file not found exception, it would be lying somewhere here. It subclasses the IO exception and the IO exception subclasses. So you got two, say, running parallel with this one, which would have an IO exception. Yeah, if you had to draw it, and a file not found exception, subclass of IO exception, which is a subclass of the java.lang exception, which means that it has to be caught and handled. Now, what do I mean by that? Look here, it's throwing an error here. And if I highlight the error, it's telling me handled exception type file not found, and add the throws declaration. So what I mean is either has to be handled or thrown. So to be handled, I could just say throws and file not found exception, found exception, and that would clear that error there. What's also interesting is, if you can see, this is a subclass of that, so I could even make this an IO exception. IO exception, and there's still no error. That is the handle part. Other part, you could have it in a try catch finally block, and for that I will come to that now, but just look what happens here. It's got no error, but I'm telling it that it's throwing the exception, so it's not handling it here. It's not handling it, it's actually throwing it. It's throwing it. So if it's throwing it, where is it being handled? Now, if you go look at my main method where it's being called now, it's telling me, oh, but this thing now is receiving a court exception that's not being handled or caught. So the same thing, I would have to catch it here, put it in a try catch block here, or I would have to throw it, and if I throw it, it will then add the IO exception here, because I'm saying even though it's a file not found exception here, it's throwing an IO exception here. So it's declaring that this exception is not being handled here. It's going to rethrow it or delegate it to the calling. So it's delegating to the main method, and the main method is decided, well, I'm not going to do nothing with it. I'm going to throw it further. So if I had to run this program now, let's see what happens. You see it crashed eventually, saying file not found exception. But remember what I told you guys about the court exceptions. They actually there so that you do something with them, like tell the client that this is a recoverable error, you've typed in the wrong file name, things like that. Okay, so I'm just going to take this out just for interest's sake, which we'll most probably touch on this later. But what if I made, you see that's an IO exception there. What if I change this one to a file not found exception? It throws an error. Why? Because even though this file not found exception there is a subclass of that one, and that is what I did here. I'm throwing a file not found exception, but I'm actually catching an IO exception here, which it's super class. That's fine, you can catch it super class, but the problem is I'm declaring this now that it's a super class in the method signature here, and yet when it comes here, it now sees, the compiler sees, okay, this thing is actually calling a method that's going to throw an IO exception, but I'm trying to catch a file not found exception. And let's just change it to file not found exception. And it's telling me, look, there's an error now. There's an error there because it needs a file not found IO exception and not the file not found exception. You can't do it the other way around. I could do this, and that would then catch the one or the other, but now why would you catch this one over there, if you already got this one catching anything of those two? So you could do that. Okay. Hope that's a bit clear to you guys. Now, let's just do the other part, which is the try catch. And for the try catch, I first want to explain to you guys what the try catch is. So let's get to it. So I'm just going to take this out, and I've got a little sketch here. I just want to get to it. And here it is. And what a try catch does, I just want to show you the sequence. If there is no exception thrown, when it goes into the try catch, the code in this block runs. Now there's no exception thrown, so it will skip the catch, but the finally, if you got a finally, it's optional, will always run. Then the next line of code, then back to the calling method. Okay. Now, if an exception does arise, so in this try block, exception arises. So you're telling it to open a file, and the file does not exist. It will catch the file not found exception here. That's declared here. And you could have another catch and so on. You will then do something with it, tell the client that there is no such exception. and then deal with it. And then at the finally will still be called. After that's done, the finally is always called, and usually this is where you'd close the resources and so on, and then the next line of code and so on. Okay, so that's what would happen over there. So let's go back to our code. Let's try catch. Now I've got one here, and the finally I'm going to just add something. So because I mentioned try with resources, here's a little program or not program, method that I've added in here. And what I want to add here is I actually want to add here because if you open resources, you should always close them. And the best place, if you're using a try catch finally, you should put your close in your finally, so that if you open a file, because it's opening files is an expensive resource in the sense that it takes time and things like that, you should close it. Okay, so I'll just add that there. Okay, so let me explain to you guys that never seen this before. I'm opening a buffered reader. Now, buffered reader is a class used to open text files in a buffered manner, a more efficient way. Okay, so it's a buffered reader. It buffers the lines and so on as it's reading. So it will not read every little byte from a hard drive, which is expensive. It will make one big write, buffer it, and another one, and so on. That's basically the idea around it. So you'll see, and now I'm going to take out this throws over here. Just take that out there, and I'm going to take this one out here because I'm calling it from here, if you recall, but I'm going to handle the exception. Okay, so you'll see that the close throws an unhandled exception over here. So we'll come back to this now, how to do it. Okay, but what we do here is when we do the buffered reader, we create a variable here, a space holder for buffered reader. Then we put it in a try block because the this file reader throws a file not found exception. If the file, and I wrote this, I described this file, no such file text, which doesn't exist. So technically, this file shouldn't exist on my system, on the default working directory that I'm working on. So I'm telling it that that the buffered reader must create a file reader, and this file reader is a lower level file that will read the file bytes, actually in text and byte characters, and then this one will buffer it. And then I've declared a string called line, and I'm reading a line at a time until null, until it comes to where it reads a null value, which means it's the end of the line. So then each line will be printed with a print line, so it will print one line, next line, and so on. And then if there's any error, it will come to a catch, and here I'm actually catching the file not found exception first for this part, and then this read line could actually throw an IO exception. If you look here, it throws an IO exception, which is actually the superclass of that one. So what happens here if it does exist, but something is, say it's a read-only file, then when this line gets called, it would throw an IO exception. So when this thing runs, it's not going to find the file, and it's going to print a message, which I'm getting from this error, from this file not found exception, variable E is going to print the get message. And then if there's no problem with that, and it had to throw, say, a read line message, it wouldn't have found that one, but it would have found this one, and I would have thrown a stack trace, Our stack trace exception you saw earlier on, it shows you the errors as it goes along. I can show you the stack trace again. We'll get to it in more videos and so on. You'll see the stack trace and so on. But let's carry on with this. And then, yeah, what you should actually do, I'm throwing an error because the close can throw an error if while it's trying, like if it's a null pointer, say it ran, yeah, I didn't create anything, so I need to catch this. But what I need to do actually, yeah, is I must say if br buffered reader not equal to null, because we must check that it's not equal to null. We must actually check and say close. Then we want it to close. Okay. If it's not equal to null, let's close it. And then let's put this in a try catch clause. So I'm just going to put it in a try catch clause there. And there's a stack trace there. We could also print a message. Okay, so that is how this works, which is basically this part here. It goes into a try. You catch it. You catch exception because it's a court exception. You have to catch it. You do something with it, and finally it always gets called. Remember, it's optional. You could have not have had a finally there, and it would still have worked. And to prove that, I'm just going to move this one down one line here, so it's easier. And the finally goes until, I believe, until there. So let's go this finally catch over there, and I think I've done one too many. Where is this one going? Okay, guys, I'm just fixed up something here. So I've uncommented the finally part. Now, if you look at this, what I said is this part is optional. So you can either have just a catch, or you can just have a finally, or you can have both. But you have to have one of the two in a try catch finally block. Okay, so you could have a try finally, a try catch, or a try catch finally. Okay, so and like I said, usually you will put your closing of your resources here, something that has to be done irrespective of what happens if this thing throws an exception or not. You want, if you're reading a file, irrespective if the file is opened and you can't read, but it's open, you still want to close those resources. So even if there's an exception thrown for some reason, a passing exception or something when you're reading the file, even if it throws an exception, it must still close your resources. So the close will be here. But remember that your close method can also, because it's reading the file in this case, can also throw an exception. So what you do there is you would then, which is the code that I uncommented here, you would actually check that object was actually created, that is not null, because otherwise it would throw a null pointer exception as well. So you check if it's not null, then you try and close it. And if everything runs fine, it will close it in this finally block. Otherwise, you're going to say, so here's a catch within a finally in this case. And then you'll catch it and you say, okay, the resources couldn't be closed for some reason, which shouldn't really happen if you open it. But anyway, yeah, that's how that is the what you do to close your resources. Now, what I wanted to show is that you don't have to have it. So I could have put the close here, which is the wrong place to put it, because then what happens if there's no exception thrown? Then your resources were never closed. Okay, so again, you usually use a finally clause to tidy up resources and stuff like that. Let's just run this, and you'll see what happened is an exception was thrown, this one over here. So it came here, file not found exception was thrown because I've got the get message here. And that's I know, and the message it's this thing here. You see it tells me no such file text. The system could not find the specified file. So what happens is it came here, it tried and opened this file, it couldn't find it, so it threw an exception, so a file not found exception. It came here and it printed out the message, and that's it. Now if I add the finally here as well, and let's run the code again, and you'll see that it still went from there, from this code here. It didn't find the file there, so it threw a file not found exception, printed that message over there, and then the finally block gets called irrespective of the exception that's thrown. And because you'll see this runs over here, and you'll see that it ran through this. It didn't throw exception, so my file, my BR, which is my reference to the buffered reader, was closed. Okay, so yeah, we did the try catch finally, and this is an example of a court exception. Okay, and what happens if, just for instance sake, I take this one out? I'm just going to go down here one line. Remember that I told you guys that the file not found exception is a subclass of IO exception. So I could actually do this. I'm just going to go one line down so I can uncomment this. What will happen now? Because it hasn't got a file not found exception, but it's got an IO exception. So if I run it now, you'll see that this always runs. The finally still gets called. This always runs, but and you can see the order is not always in the same order because it's your system is scheduling. But don't worry about that. What's happening here is when this gets called, this is a file not found exception that gets called here. But the file not found exception is a subclass of the IO exception, and I didn't catch the file not found exception. I just caught the general IO exception, of which all your file not found and other exceptions extend. So because it didn't have this one, but you got that one, it gets caught at the next level. Okay, and finally it still gets caught. Obviously, if you do this, now you've got a problem because you've got two exceptions here. You see here, you got the file not found exception there, file not found exception, and you got an IO exception that hasn't been handled. Remember, your finally doesn't handle those exceptions. It runs irrespective of if exception is thrown or not. Okay, now it's generally good practice to call a specific exception as you can. In this case, because there's a file not found exception and a reading IO exception. If you just use this one, it's obvious that the user won't really know what was wrong with that file. Was it a wrong file name that I entered, or is it something when it was wrong with the file itself? A read-only file, or there's something inside, something wrong with the file, but it opened it, but it couldn't read it. Now, in this case, you wouldn't know what's the issue. So exceptions in general, you shouldn't make it top level down, because I could even have done something like this. Let me show you. I'm just going to take this one out, and I'm going to make this one an exception, and it will still work. But if I run it, it's going to tell me a file not found exception is thrown, but it's a very high level exception here. Okay. So generally try and catch them at a high level, because then over here I could then put here a message to user. The file, when there's a file not found exception, I can print out a message here. The file was not found exception. Yeah, I could say something like could not read, and I could put in some further description over there at line 12 in the file, could not be read or something. Okay, so just to show you something else quickly. Okay, so I just want to show you guys that this actually is working. Instead of throwing exception, I've actually put in a file that exists on my D drive. It's text of a short story, Alice in Wonderland. And so if I run it, there's it. So the whole Alice in Wonderland gets thrown. So what's happening here, I'm opening the file which does exist. So this file not found exception is not called. It's not thrown, in other words. Then, like I said, yeah, in this while loop, the line, it reads a line into the buffer, and it prints out the line onto my standard console, which is my console window in this case. So it's reading it and throwing it out line by line until it comes to null. That's just to explain what this method is doing. So it's working 100%, yeah. Okay, guys, now we're going to go on to the next one, which would be the error, this one here. So I'm going to just comment that one out and open this one, and you'll see I've got a method it's calling a method throw error, which is over here. So I'm just going to open this one, and what I'm going to do here in this one, I'm just going to throw and what I want, oh no, sorry, I'm on the wrong one. Just scratch that. That is a throwable. It's this one here. So let me explain to you what's happening here. Yeah, I've actually got a class called random that creates random numbers basically. And I've got a map that's storing, guys that don't know about, just haven't done maps and things, just bear in mind, just keep the whole idea of this is to the concept, just understand the concept of exception handling we're dealing with here. You can always go read up or later on look at my videos that will come have done or will come in the future about maps and so on. So you're storing a map with two integer values. The first one is the key of the map, and then that key is storing another integer value just for simplicity. And I'm creating it as a hash map, and I'm starting my index as my index, which will be that one as 0. Then I'm saying while it's true. So this is a loop, and it's going to be always true. It's never going to end because I'm telling it it's true, so it will never be false. So what happening is while it's true, I'm saying put 0 plus plus. So it's going to at 0, it's going to put a random int number. At 1, it's going to put another random int number. At 2, it's going to put another random int number, and it's never going to stop. Now, what happens in such a case is it's never going to stop, and it's almost like the concept of my vehicle. it's going to carry on forever and ever and ever. So let's see what happens if I just want to clear this console here. Let's run this and see what happens. Okay, there it's running, and you can see it's running because this light here is this little indicator here is red, and I don't see any output now. Reading. Okay, I didn't tell it to print anything, so it's just putting random integers a map the whole time, and it's getting on and on. I don't really know what's happened. Oh, something happened. What happened? Oh, an error occurred. Eventually, the heap where this map is storing information ran out of memory because it kept on putting things, and you get a lang out of error heap space. You see? Okay. It's a out of error message, which if I go and look what's an out of error message, we can go here and just say Java, my little app again, and I'm just going to say java.lang lang. I think it's java.lang out of memory error. So let's put in there out of memory error, and I don't think I spelled it right. Let me just try this. It's out of memory error. I think it's right, but be safe if I copy that and rather paste it in there just to be sure. Just take that last couple of chunk out there, and I say, and you see the out of memory Java-lang out of memory error is a subclass of a virtual machine error. Your JVM that's running this is a virtual machine error, and that subclass is, so it's a subclass of your error. So as at the beginning I explained, this will be the analogy, same as what we would call my example of run. You know, there was a hole in your sump and it started losing oil, and you must pull the car to the side. So that's now an example of out of memory error. Yeah, and remember the throwable? Yeah, you could also actually throw a throwable, and that's what I want to show you. Yeah, I'm actually just to see what it does. I'm going to throw a throwable here. And what happens with a throwable? A throwable is just like your java.lang.exceptions, and those are subclass exception. It has to be handled or caught. Okay, so you could create classes to extend throwable to handle caught, but in general you'd use your more specific class for that. And the only one that you don't have to catch, which you as a programmer should be using these two, this one, yeah, you don't have to handle or put it in a try catch, but you can, because this one is for programming exceptions, state object state that hasn't been initialized properly, and so on. So you shouldn't really catch him. Where this one should be for recoverable, and obviously this one is for something went wrong with the system, like I mentioned in the beginning, like you're opening a file and suddenly your C drive goes corrupt or something, it crashes and stuff like that. So yeah, that I think I've come to the end of this lesson. Just to show you, I can actually say declare it, and I say throwable, and there that is now correct. I hope you guys enjoyed this video. It was quite a lengthy one compared to the previous one, and thank you, and see you next time. Okay, so ciao for now.